Hi everyone. The topic we are going to see today is page replacement algorithm. Under this page replacement algorithm, we have already seen one methodology, FIFO page replacement algorithm. Now we are going to see about optimal page replacement algorithm. The concept of optimal page replacement algorithm is that while selecting the victim frame, the data which are least frequently used in the upcoming string will not be selected as an victim frame. That is the concept of optimal page replacement algorithm. Let's see this with an example. The inputs given are the sequence of string and the number of page frames. Here the frame size is 3. In this, the input string arrived is 701, 203, 042, 303, 212, 017 and 01. In this, since the frame size is 3, we are keeping the box size as 3 and the first string arrived is 7. It is allocated to the frame 1. Next string arrived is 0. It is allocated to the frame 2. The next string arrived is 1. It is allocated to the frame 3. Then the value of 2 arrives. In this, since all the 3 frames are filled, we are going to select the victim frame. In victim selection of optimal algorithm, the simple concept used is the data or the frame which are going to be used frequently in the next upcoming string will not be selected as victim frame. The data available is 701. While considering the sequence of next arrival string 2 0, 0 is arriving frequently, so we won't select 0 as an victim frame. Next 3 arrives. Since 3 is not available in the frame, it is not considered. Again 0, again 4, 2, 3, 0, 3, 2, 1. Since 1 is available in the frame and 1 is least frequently arriving in the sequence, we won't select 1 as a victim frame. So the only possible option is 7. So 7 is the victim frame we are selecting here. So we are replacing the value of 7 with the new arrival string data 2. Now the data in the frames are 2, 0 and 1. Next arrival string is 0. Since 0 is already available in the frame, it is not modified. The next string arriving is 3. Since 3 is not available, we have to select the victim. In this, the data available is 2, 0 and 1. While considering this, we have to see the next arrival string sequence. In this, 0 is arriving next, so 0 is not selected as victim. Next 4 and next 2 arrives, so 2 is also not selected as victim frame. The only possible option is 1. So 1 is selected as victim and in the position of 1, 3 is replaced. Now the data in the frame are 2, 0 and 3. Since the next arrived data is 0 and already available in the frame data are not modified, we are skipping to the next arrival string. The next arrived string is 4. Since 4 is not available, we are supposed to select the victim frame. The same concept, the already available data are checked with the next arriving data. In this, the frame data are 2, 0 and 3. While checking the arrival sequence, after 4, 2 arrives. So 2 is not selected as a victim. Then 3 arrives. So 3 is also not selected as victim. The 0 is the only available position. So in the position of 0, we are replacing the value with 4. Then again, we are going to next string. The next string arrived is 2. Since it is already available in the frame, we are not doing any modification. We are skipping to the next arrival string. The next arrival string is 3. Since it is also available in the frame, we are not doing any modification. We are moving to next arrival string. The next arrival string is 0. So 0 is not available in the frame. We have to select the victim frame. The data available in the frame are 2, 4 and 3. In this, the least frequently arriving data are 3 and 2. So these two are not selected as a victim. In the position of 4, 0 is replaced. Again, we are moving to next string. Since 3 is already available in the frame, we are moving to next arrival string. 2 is also available in the frame, so we are moving to next arrival new string. New string arrived is 1. Since 1 is not available, we have to replace the data and select the victim. The victim selection is based on next frequently used is not selected as victim. So while considering the sequence, 2 and 0 are arriving next after 1. So these two are not selected as victim. The value of 3 is selected as victim. In the position of 3, new arrival data 1 is replaced. Then we are moving to next new arrival string. The new arrival string is 2. It is already available in the frame. So we are not doing any modification. We are moving to next string. Next arrival string is 0. It is also available in the frame. So we are not doing any modification. We are moving to next string. The next arrival string is 1. Since it is also available in the frame, we are not doing any modification. We are moving to next arrival string. The next arrival string is 7. Since 7 is not available, we have to select the victim frame. In this, the available data are 2, 0 and 1. 0 and 1 are the data which are next going to occur in the sequence frequently. So we are not selecting 0 and 1 as victim. In the position of 2, we are selecting 2 as a victim, and in the position of 2, the new arrival data 7 is replaced. Again, when we check for the next string, 0 is already available and next 1 is also available, so we are not doing any modifications. So this is the allocation of optimal page replacement algorithm. In this, the total frame changes and modification done are for 7, 0, 1, 2 and 3 and 4, 0, 1 and 7. So the total page fault occurrence is totally 9. 9 is the occurrence of page fault for this problem under optimal page replacement algorithm. While considering these three techniques, FIFO page replacement algorithm, optimal page replacement algorithm, and least recently used page replacement algorithm, the optimal page replacement algorithm will be having the lower page fault rate. But the only disadvantage of this is we must be aware of the next arrival string priorly, then only we can select the victim frame. Since that is not possible for all the problem, this optimal algorithm is not most probably used for page replacement technique. Let's see the same problem under next algorithm technique least recently used.